Students, all of you, good evening. Welcome to the session. Is it audio is clear? Can you please confirm? Thank you. Continuation of network theory, that is circuit theory. With respect to chapter 1, that is fundamentals of electrical circuits. I'm going to starting lecture 3. In the previous session that I discussed what exactly Ohm's law, what are the limitations of Ohm's law. Students, we know that if the current is flowing through the conductor, there is an opposition for the electrical energy. For the flow of electrical energy, there is opposition. The opposition for the electrical energy is continuous or distributive in nature. It may be continuous nature or it may be distributive nature. But practically, the opposition for electrical energy flow is approximated as distributive. That is, you have to represent the opposition for electrical energy by using the three lumped parameters. We can approximate this distributive opposition into three lumped oppositions called resistance, inductance, and capacitance. If the electrical energy is flowing through any conductor, for the flow of that current or that electrical energy, there is opposition. That opposition is represented into three lumped oppositions called resistance, inductance, and capacitance. That's the reason why resistance, inductance, and capacitances are introduced in the conductor. But this is for lower frequencies. But point to remember, friends, network theory is valid for lower frequencies, maximum up to 1 megahertz. What is the reason? Up to 1 megahertz frequency or lower frequencies only, we are approximating distributive as a lumped. But at higher frequencies, we can't approximate a distributive as a lumped elements. Later we'll see what exactly lumped elements, distributive elements. Up to lower frequency or up to 1 megahertz frequency only, we have to approximate the distributive as a lumped nature. That's the reason why the circuit theory is valid only for lower frequencies or maximum up to 1 megahertz. At higher frequencies, that is above 1 megahertz, we cannot approximate distributive elements into lumped elements. And hence, there is no lumped electric circuit. There is no network theory. Here, the field theory approach is used directly on distributive conductors. If it is a lumped conductors or lumped approximation, then you have to apply network theory. If it is a distributive conductors, then you have to apply the field theory approach. That's why for higher frequencies, which approach is preferable? Field theory approach is preferable. But for lower frequencies, network theory approach is preferable. Because for lower frequencies only, we can approximate a distributive as a lumped. Then only network theory concept is applicable. For higher frequencies, we can't approximate distributive as a lumped. That's why there is no concept of network theory. We have to apply the field theory students. Now we are introducing the three elements. One is resistor, another one is inductor, third one is capacitance, to represent the opposition for the flow of electrical energy in the conductor. There is a three parameters. One is resistance. One is resistance. Another one is inductance. Inductance. Third element is capacitor. This is a capacitor. This is inductance and this is the capacitance. For example, if you are applying the voltage across the resistor, potential across the resistor is V, then you have to take the, whenever current is flowing, I, then this polarity is also, wherever the current is, this is plus minus, then you have to take the, wherever the current is entering, you take this is plus and this is minus. The reason is the polarity of voltage and the polarity of current direction. Wherever the current is entering, you are taking plus. Then this is minus. Why you are taking this one? This polarity and this polarity is same. The reason also I will explain. Let this is the current direction and I apply the voltage like this, and this is also plus minus. If you are applying the voltage, then the voltage drop across the resistor is, this is the, for clear understanding, you take like this. let we are applying the V voltage, V is the supply voltage. Now current is flowing through the resistor. There is a drop. Then drop is also taken as the same polarity. Let here also we are applying the voltage V. We are applying the voltage V. V is the supply voltage with this polarity. And the current is flowing. Then voltage across the inductor VL. This also taken with the same polarity, plus minus. If the current is enter, you take positive, then this is negative. The reason also I will explain, friends. And this is the voltage. It is taken like this. Then if the current is flowing, wherever the current is entering, this is taken as a plus, this is taken as a minus. The reason is the polarity of this voltage and current is same. Students, we know this. What is E equal to? V by L. What is J equal to? I by A. E direction, V direction, I direction, J direction is same. I told already. Current is in the direction of electric field only. Then this E equal to V by L means this electric field and voltage also same direction. Because of this is same direction, if electric field is plus minus, voltage also plus minus, for current also you have to take the plus minus. Even for current density also you have to take the plus minus. This is the reason, friends. I told already, electric field and current is in the same direction. If electric field and current is in the same direction, this electric field equal to voltage per unit length, na? That's the reason why voltage and current polarity is also same. See, for example, friends, this is the resistance. This is the resistance. This is the current direction. This is the current direction. Then this, according to this current direction, this is taken as a plus, this is taken as a minus, because this is plus minus. Wherever the current is entering, we taken as a positive. Why? This is the reason. The polarity for voltage and current, wherever the entering, it is a positive. See, for example, when I change the polarity like this, now the current is flowing like this, positive to negative. Now this is taken as a plus, this is taken as a minus. Why? This polarity and this polarity is same. These two are in the same direction. Electric field and current is same direction. Voltage and current is also same direction. Now I'm asking one question, friends. Why resistance in the conductors? Why resistance in conductors? Why you have to consider the resistance in the conductor? I told already, for the flow of electrical energy in the conductors, there is opposition. That opposition is represented by, actually that opposition is either continuous or distributive. But even that is a distributive, for lower frequencies up to 1 megahertz, it is approximated as a lumped. That's why we are using 3 lumped parameters. But this concept is applicable up to 1 megahertz frequency one. Now I'm asking the question, why resistance in a conductor? Let's consider any one conductor, students. Let's consider any one conductor. This is the one conductor. Within the conductor, there is some ions. Ions are present. There is some ions within the conductor, like this. These are tightly bound to the atoms, and there is some electrons also. In any conductor, there is a freely moving electrons. Electrons. If the electric field is applied, if the electric field is present, then there is a force on electrons. Because of that force, the electrons are moving like this. The electrons are moving like this. Because of force, what is the force equals, friends? Minus E into E bar. Sorry, minus E bar into E. That's why the force is opposite to electric field, you know. This is the electric field direction, and this is the force direction. I'm explaining why resistance in the conductor, friends. Clearly understood? Because of the force, the electrons are moving in the conductor. But because of this electric field, whatever these ions are present, these ions are not moving. These ions are vibrate about its position. These are vibrate. These ions are vibrate, friends, like this. About its position, these ions are vibrate. When these are vibrating, during movement of these electrons, once these ions are vibrating, electrons are moving. If the ions are vibrating, which obstructs the flow of the electrons. Because of these vibrations, for example, this electron is moving like here. Now it is vibrating. Once it is vibrating means which obstructs the flow of electrons. This obstruction or opposition is given by the resistance. This obstruction or opposition is given by the resistance. That is, if electrons are moving in conductor, if electrons are moving in conductors, if electrons are moving in conductors, the ions are vibrate, the ions are vibrate about its position, its position, obstruct the or oppose the flow of electrons, oppose the flow of electrons, oppose in the sense which obstruct the flow of electrons, oppose the flow of electrons. These ions will not move, students. These ions are tightly bonded to that atom. Because of this external field, they vibrate only. Once they are about its position, it is vibrating. It is moving up and down like this, up and down. If it is vibrating, once the electrons are moving, there is some obstruction, flow of electron. Its position oppose the flow of electron. It is called resistance. It is called resistance. That's why if electrons are moving in conductors, the ions are vibrate about its position, oppose the flow of electron, then it is called the resistance. That's why resistance is represented in the conductors. Why resistance in the conductor? Because of this opposition. Clear, friends? With this knowledge, now we have to start with what is the resistance, what are the different types of resistors, what are the formulas with respect to resistors, okay, then what are the properties of resistors, all these observations that you have to see. Based on these observations and formulas of resistance, already questions are there in different competitive exams. What is the resistance terms? I think all of you well know this. It's a very simple definition. Materials in general have a characteristic behavior of resisting the flow of electric charge. This physical property or ability to resist current is known as resistance and is represented by the symbol R. This is what exactly the definition of the resistance is. Resistance is the property which opposes the flow of current or which opposes the flow of electric charge. And it is represented by the symbol R. A resistor is a passive component. A resistor is a passive component in a circuit which provides resistance to the flow of current. A resistor provides the resistance to the flow of current. Students, see the difference here. Resistor is the physical element. Resistance is the property. Don't confuse. Resistor is the physical element. Resistance is the property. Resistor having the property of resistance. Because of that property, which opposes the flow of current. The circuit element used to model the current resisting behavior of material is the resistor. The current resisting behavior of a conductor is modeled as a resistance. For the purpose of constructing circuits, resistors are usually made from metallic alloys and carbon components. We have to use metallic alloys and carbon components. Okay, this is what exactly? Resistance and resistors. What are the different types of resistors are available? There is a carbon composition resistors and there is a thermistor is also a resistor. Wire wound resistors. Practically there is so many types of resistors are available. Metal film resistors and carbon film resistors. There is a variable resistors. And there is a non-linear resistor or varistor. Light dependent resistor, that is LDR students. Light dependent resistors. LDR. Each resistor is having its own behavior. There is a non-linear resistor or light dependent resistor. There is a different types of resistors are present. But point to remember, students, there is a linear resistors and there is a non-linear resistors also. Linear resistors are present. Even non-linear resistors also present. Why it is a non-linear resistor? Later on that I will explain. But there is a concept of linear or non-linear resistors. But generally, I told already, Ohm's law is applicable only for linear, not for the non-linear case. Yes. Now how to explain what is the dependence of resistance on various parameters? How the resistance will depend on different parameters or different factors. How to write very important observations that I have to explain here. Yes. Dependence of resistance. Dependence of resistance. Resistance on various factors. on various factors. On various factors. Dependence of resistance on various factors. One is, we know that the resistance R equal to rho L by A. Rho L by A. The resistance R equal to rho L by A. This formula already you know. That is, resistance is proportional to length of the conductor. Resistance is inversely proportional to cross-sectional area of the conductor. And resistance is proportional to length, and resistance is inversely proportional to cross-sectional area of the conductor. It depends on the length of the conductor. It also depends on the cross-sectional area of the conductor. This is one observation. The second one is, for example, if the conductor is stretched, or if any wire is stretched, conductor, this is wire is one conductor. On stretching the wire, very important observations. Keeping volume of the conductor is constant. Keeping, you are stretching the wire, keeping volume equal to constant. Keeping volume equal to constant. On stretching the wire, keeping volume equal to constant. Let this volume be V. This is the volume of the conductor. This is equal to constant. Now, in this case, what are the observations, friends? First one, I'm writing. For this case, first one, we know that R is proportional to L by A. R is proportional to L by A. You multiply and divide into A squares. Multiply, divide into A. Multiply into A and divide by A. Then what you can get, friends? R is proportional to AL by A square. That is proportional to, what is A into L? Volume by A square. But we are assuming that the volume of the conductor is constant. This is constant. So, volume is constant, then R is proportional to A square. The resistance is inversely proportional to square of the cross-sectional area of the conductor. Very important observation. At constant volume, R is proportional to, the resistance is inversely proportional to cross-sectional area of the conductor. During solving of the problems, this observation is important. But you have to concentrate. Therefore, how we can write, friends? R2 by R1 equal to A2 square by A1 square. A2 square by A1 square. This is at a constant. Let's assume that if the radius of the conductor is smaller, if the radius of the conductor is smaller, the radius of the conductor is smaller, let it is a circular conductor, conductor is smaller, and if it is a circular conductor, then you have to write A equal to pi r square. Then what about A square? A square is proportional to r to the power of 4. A equal to pi r square means, what is A square? A square is proportional to r to the power of 4. Then from this, what you can write, friends? R is proportional to 1 by r to the power of 4. That means all these observations are at a constant volume. If volume is constant, resistance is inversely proportional to square of the area, and resistance is inversely proportional to r to the power of 4. Inversely proportional to r to the power of 4. Then how we can write R2 by R1 equal to r to the power of 4 by, sorry, R1 power of 4. This is wrong, friends. Sorry, it is inversely proportional. It's A1 square by A2 square. Correct it. It's inversely proportional. Na? It's A1 square by A2 square. Then how you can write this one? R2 by R1 equal to R1 power 4 by R to the power of 4. R1. It is inversely proportional. R1 power 4 by R2. Even if you take the even diameter also, if R is the diameter, so R is the radius. If D is the diameter, if D is diameter, you have to take if D is the diameter, how you can write R2 by R1? If radius is inversely proportional, means even diameter also inversely proportional, then R2 by R1 equal to D1 power 4 by D2 power. It is also inversely proportional. Diameter is given or radius is given, you have to apply this relation. This is the second observation. Stretching the wire, keeping volume is constant. Next. See the third observation here. Third observation. Let L is the original length of the conductor. Corresponding to original length, the resistance is R1 students. Let L equal to original length of the conductor. Original length of the conductor. Original length of the conductor. Corresponding to original length of the conductor, the resistance is R1. Let the length of the conductor is increased by X%. Let length of the conductor, length of the conductor, length of the conductor is increased by X%. Very important observation to solve the problems. Increased by X%. If the length of conductor is changed, what about the resistance? The resistance is also changed. Let that resistance is R2. After the length is increasing, the resistance is R2. Then what is the relation between these two friends? Directly I am writing. Then R2 by, no need of any derivation, directly I am writing. R2 by R1 equal to, how to write, L square into 1 plus X by 100 whole square by L square. This you have to write by L square. This R2 by R1 equal to L square into 1 plus X by 100 whole square by L square. Yeah, this is the relation. Then if you simplify this, nearly we can get, how to write like this, R2 by R1 equal to R2 by R1. Both sides I am doing the minus 1. Both sides I am doing the minus 1 students. Then L square into 1 plus X by 100 whole square by L square minus 1. Then R2 minus R1 by R1 equal to, then L square into 1 plus X by 100 whole square minus L square by L square. Then take L square is common, that will be cancelled. Then what is R2 minus R1 by R1 equals to? This is equal to, take L square is common, 1 plus X by 100 whole square minus 1. Here also you can cancel, no problem. But here I am writing like this. 1 plus X by 100 whole square minus 1. Yeah, that is cancelled, no problem. Finally it is cancelled. Here also you cancel, no problem. Then this is nearly equal to, by simplifying these friends, this nearly you can get a, you want percentage. What is the percentage change in resistance? What is the percentage? Due to change of length, the length is changed by X%. The length is changed by X%. Then what is the percentage change in resistance if it is asked? What is the percentage change in resistance? Then R2 minus R1 by R1 into 100. This is equal to percentage change in resistance. This is a percentage change in resistance. Percentage change in resistance. The percentage change in resistance, this is nearly equal to, you have to simplify this one, nearly you can get a 2x%. Direct formula. How to remember this one? Is nearly equal to 2x%. That means if the length is increased by x%, then the percentage change in resistance is 2x%. You have to apply binomial theorem here. Then you simplify this one. Approximately, you can get the percentage change in resistance delta R by R into 100. This is equal to delta R by R into, or delta R by R1 into 100. What is the delta R here? R2 minus R. This is the third observation. If the length is increased by x%, then resistance also changed by, the resistance is changed by 2x%. This is the third observation. How the different factors will affect the resistance? One is how the resistance depends on the length and area. Keeping volume is constant, if the wire is stretched, how the resistance will depend on the area, how the resistance will depend on radius, how the resistance will depend on diameter stretch. If the length is increased by x%, then what is the percentage change in resistance? The percentage change in resistance equal to 2x%. Next, one more observation that I have to explain here is the fourth observation, students, that you have to concentrate. We know that R equal to rho L by S. R equal to rho L by A. Shall I write like this? Multiply and divide with L. Multiply and divide with L. This is rho L square by V. Rho L square by V, where V is the volume of the wire. Then this is rho L square by V. We know that what is the density of the conductor or density of wire, students? What is the formula for density? Mass per unit volume. mass per volume. This is the density. That is m by v. From this, what you can write? V equal to m by d. I'm writing in terms of density. Then what is R equal to rho L square by this volume? I'm not maintaining volume is constant. I'm not assuming volume is constant. This is m by d. This is equal to rho L square by d by m. Rho L square, that is rho L square d by m, where d equal to density of the wire or density of the conductor. Like this, how the resistance depends on density, mass, and length of the conductor. Yes, friends, this is the fourth observation. Now we know that what is the effect of temperature on resistance? Effect of temperature on resistance. Effect of temperature on resistance. The effect of temperature on resistance. Students, we know that R equal to rho L by A. Rho L by A. Yes. R equal to rho L by A. And you have to write this equation in terms of the drift velocity, or we know this one, R equal to rho L by A. What the resistivity, students? The resistivity equal to m by n e square tau. Please go through the first today lecture, that relations I given. Rho equal to m by n e square tau, where n is the number of electrons, m is the mass of electron, e is the electron charge, tau is the relaxation time. Now you substitute here, what you can get, friends? ml by n e square tau a. N e square tau a. We know that in conductor, if temperature is increases, in a conductor, if a temperature is increases, if temperature is increases, if temperature is increases, the electrons are accelerated. The electrons are accelerated. Electrons accelerated. When the electrons are accelerated, there is acceleration is increases. What is the collision? There exists a collision of the electrons. Collision is increases. If the collision is increases, what is the conductivity? Decreases. If the conductivity is decreases, what about the resistivity? Increases. What about the resistance? Resistance is increases. That means due to temperature, if temperature is increasing, what about the resistance? The resistance also increases. The temperature is increasing, the resistance is also. That is the effect of temperature. That is the effect of temperature on a resistance. If the temperature is increases, the resistance is also. Then if you draw the characteristics, resistance versus temperature, I told already this one. If you draw the characteristics between resistance versus temperature, then if the temperature is increases, the resistance is also increases. Let's assume that alpha is the temperature coefficient of the resistance. Let alpha equal to temperature coefficient of resistance. Temperature coefficient of temperature coefficient of resistor in per degree centigrade. In per degree centigrade. Then if R naught is the initial resistance, if R naught is the initial resistance, or R1 is the initial resistance, let R1 is initial resistance. Initial resistance. Due to change of temperature, due to temperature, the R1 is changing from R1 to R2. Then how to calculate R2, students? All of you well know this formula. R2 equal to R1 into 1 plus alpha into delta T. This R2 equal to R1 into 1 plus alpha into delta T, where delta T equal to change in temperature. Change in temperature. Yeah, this is the effect of temperature. This is the effect of temperature on a resistance. If the temperature is increases, the resistance is increases. We know that not only the resistance, if the temperature is increases, what about the resistivity? The resistivity is also increases. Then let rho naught is initial resistivity. Initial resistivity. Then due to temperature, then rho t equal to, you have to write rho naught into 1 plus alpha into delta t. Alpha into delta t. You can also write resistivity in terms of temperature coefficient. This is initial resistivity or resistivity at a T1 temperature. Or you have to take any temperature, either T0 temperature or T1 temperature. That's no need to write. But these are the relations that you have. Like this, based on the temperature, that is, the resistance depends on the temperature. These are the different factors which affects the resistance of a resistor. Resistance of a resistor. Before this, I have to give one observation. I told already. There is a linear resistor and a non-linear resistor. What is the difference between the linear resistor and non-linear resistor? That you have to concentrate. Just a minute, I'm adding the slide. Yes. This note you have to concentrate. We know that R equal to the resistance R equal to rho L by A. And we know this I equal to V by R. I equal to V by R. From this, already in the Ohm's law, I given already R equal to V by I. R equal to V by I. Then for linear resistance, for linear resistance, for linear resistance, if you draw the characteristics, if you draw the character, this already you know, V versus I characteristics. V versus I characteristics. V versus I characteristics is like this. You find the slope. The slope gives the resistance R equal to V by I. This remains constant. If it is remains constant, then V is proportional to I. If V is increases, what about I is also increases. This is for linear resistance. Most of resistors are the linear resistors. In some resistors are having the non-linear characteristics. Now, if you take non-linear resistors, when the particular resistance is said to be non-linear resistor, for non-linear resistor, for non-linear resistor. Non-linear resistance means, example is metal oxides. Example, metal oxides. Metal oxides are having the non-linear behavior. If you take any non-linear behavior, if you draw the characteristics between V versus I, V versus I, then you let this is the non-linear characteristics. This is the non-linear characteristics. This is the non-linear characteristics. Then how to find the slope for non-linear characteristics? Can anybody? How to find the slope for non-linear characteristics? For any non-linear characteristics, to find the slope, you have to draw the tangent. By drawing the tangent, you have to find the slope by drawing the tangent. Then if you draw the tangent, then this is the theta, this is the theta, and this is the theta, and this is the theta. The slope gives slope equal to, for any nonlinear characteristics, you have to find the slope by drawing the tangent. The slope of the tangent is tan theta, that gives the resistance. Slope gives the resistance. But here slope is not directly V by. The slope equal to depends on the theta. Slope depends on the theta. Then tan theta equal to R. Now what is your observation, sir? In these characteristics, what about theta? If current is increasing, in this current is increasing, what about this angle? This angle. Slope is reducing, angle is reducing or not? That is, if I is increasing, what about the theta? Can anybody? If I is increasing, what about theta? The slope is, at different points you find the slope, friends. At different points you find the slope by drawing the tangent. The slope is slowly reducing. This is reducing. That theta is reducing. If theta is reducing, what is tan theta? Reduces. If tan theta is reducing, what about R? Reducing. If tan theta is, that is, if I is increasing, R is changing. If the current is changing, resistance is changing. Is it resistance is constant? Is it resistance is constant, friends? This is variable resistance. Non-linear resistor is the variable resistance. Variable resistance. But I told already, If R is constant, then only Ohm's law is applicable. Ohm's law is applicable. Ohm's law is applicable. But for non-linear resistor, Ohm's law is not applicable. Ohm's law is not applicable because resistance is variable here. Not applicable. That's why I told already. Take the example of diodes. Diodes are having a non-linear behavior. It is having a non-linear characteristics. You don't apply Ohm's law. Even metal oxides is also having a non-linear characteristics. That's why don't apply Ohm's law. Clear, students? Yeah, this is what exactly? A non-linear resistance is nothing. It is having the variable resistance. But as for Ohm's law, R is constant, then V proportional to I. Then it is applicable. But here R is not constant. The current is changing, resistance is also changing. That's why these are nothing but a variable resistance. Then you don't apply Ohm's law. This is what exactly non-linear resistance. Clear, student? Understood? Linear behavior and non-linear behavior. Linear behavior R is constant. You find the slope at any point, it is constant. But it is not constant, it is changing. Current is changing, resistance is also changing. There is difference between linear resistance and non-linear resistance. Now the question is it negative resistance are exist? Can anybody? Is it negative resistors are exist? Practically, nothing is the negative resistor. Negative resistors are not possible, sir. Negative resistors are not possible. Resistor is the one physical parameter, na? Resistor is one physical parameter. Physical values never be negative. Physical values never be negative. But then what is the meaning of negative? It is not a negative resistor. Negative resistance characteristics. Negative resistance is the characteristics. It is not a value. That is, practically, there is nothing called negative resistance. But negative resistance is the characteristics. When the current decreases as the voltage increases. The current decreases as the voltage increases. See this one. This type of characteristics you seen in the tunnel diode. If the current is, this is called tunneling effect. If the current is increases, so if the voltage is increases, the current is decreases. This type of characteristics are called negative resistance character. Resistance never be negative, sir, but it's a negative resistance characteristics. Characteristics is the negative. Why the name is given as a negative resistance characteristics? Actually, if the voltage is increases, current must be increases. But here, what I'm telling that the voltage is increasing, current is decreasing. Okay, this is even one more example is, can anybody give one more example for negative resistance characteristics? UJT, unijunction transistor. UJT is also having a negative resistance characteristics. Negative resistance characteristics. UJT is having the negative resistance characteristics. UJT is having the negative resistance characteristics. Even tunnel diode is having the negative resistance characteristics. Even gun diode is also having the negative resistance characteristics. That's why you don't have any negative resistance, but negative resistance characteristics are exist. What do you mean by negative resistance characteristics? If voltage is increases, current is reduced. Voltage is increases, current is reduced. Okay, these are called negative resistance characteristics. This I told what is the non-linear resistor. These are the example for non-linear resistors. Non-linear resistors are those type of resistors where the electric current flowing to the, it changes with change in applied voltage or temperature and does not according to Ohm's law. The resistor which cannot follows the Ohm's law. Which cannot follows the Ohm's law. Okay, that is nothing but a non-linear resistor. Okay, this LDR, light dependent resistor is the non-linear resistor. Light dependent resistor is the non-linear resistor. Okay, the slope is not constant. If you find the slope at any point, this is the theta. At different points, if you find the slope is decreasing. The slope is decreasing. Then what the slope equal to, friends? This is R. This is equal to tan theta. Then if I is increases, this one voltage and current it is strong. Actually, you have to find this is voltage and current. This slope you have to take. This is I you have to take. V. I am taking this is V, and this is I squares. I. Then if I is increases, theta is reduces, tan theta reduces, R is also reduces. These characteristics are nothing but a non-linear behavior. Clear? Any doubt? Next. Yes, friends, can you answer this question? Anybody? Try this. Before this solving the problems, I have to explain one more concept. After that, you will see the problem solution. Just a minute, I'm adding the slide. There's a different models of questions are there. No doubt. Yes, students. Now you have to concentrate what is the power dissipated by resistor. This you have to write. The first one is power dissipated by resistor. Power dissipated by resistor. By resistor. Then what is the formula for power dissipated by resistor? We know that power equal to V into I. Now for resistor, voltage across resistor is voltage across resistor. How much, friends? IR. Voltage across the resistor is VR equal to. Then you have to write what is the power dissipated by the resistor. That is VR into I. That is what is the voltage across the resistor? IR. This is IR into I. And also that is equal to I square R. The power dissipated by the resistor equal to I square R. We can also write I equal to V by R. I equal to V by R. Then one formula for power dissipated by the resistor is I square R. Then one more formula for power dissipated by the resistor equals to, how to write V by R whole square into R. This is equal to, how to write V square by R. The power dissipated by the resistor is PR equal to V square by R. This one formula that you have to concentrate. Then this is a formula for power dissipated. Then how to calculate the energy dissipated by resistance? Energy dissipated by resistance. Just a minute. Then how to write energy dissipated by resistance? Energy dissipated by resistance. The energy dissipated by resistance is, you know the formula for energy. I will explain how to write energy equal to, or you can use either ERW, integral PDT. Integral PDT. This is equal to, what is P? I square R. I square R into dt. Then I square R is constant now. I square R into integral dt. Integral dt is the t. That is I square R into t. Then energy dissipated by the resistor equal to ERW, that equal to I square R into t. This is also equal to V square by R into t. It's also equal to V square by R into t. This is energy dissipated by the resistor. Next. And one more point you have to remember here. This I am giving. This is the power dissipated by resistor, and this is the energy dissipated by resistor. That is V square by R into t. That is I square R into t. I'm asking one example. What is the practical example of resistor, students? Which having the resistance property, which having only resistance property. Then can anybody tell what are the practical examples of resistive resistors? The practical example of resistors are one is heaters, resistive nature. The next one is which having the resistive nature, incandescent bulbs. Incandescent bulbs is also example of resistive nature. Incandescent bulbs. Then one more example is iron box. Iron box is also having resistive nature. Domestic and industrial wirings. Domestic and industrial wirings also having resistance. Industrial wirings. Every conductor is having some resistance. Industrial wiring, there is a resistance effect. Machine windings also having the resistance effect. Machine windings also having resistance effect. Even starters, you know that. Electrical students, you know this. Starters also having the resistance. Starters also having the resistance. Electrical students, you know, 2-point starter, 3-point starter, 4-point starter in DC missions, that is the starters. Even transmission lines also having the resistive nature. These are some practical examples. Even transmission lines also, you don't neglect resistance of the lines. No? Only for short transmission lines, you can neglect the capacitance. But in most of all the transmission lines, medium lines and long lines, you have to consider the resistance, inductance, and the resistance. But one point to remember, so this observation is important during solving the problems. Heater rating. Heater is the example of which one? Resistive. Then heater rating is specified as P equal to V square by R. The heater rating is specified as P equal to V square by R because it is a resistive. Okay, this points mainly for to concentration. Now with this knowledge, now we have to start some questions. Can anybody answer this one? Then after this we go for the concept of color coding. Then we'll start inductance. Two wires of same material have their lengths in the ratio of 2:3 and the radius 8:9. Equal value of potential difference is applied between their ends. Calculate the ratio of current to two wires. Calculate the ratio of current to two wires. Ratio of their length ratio is given and radius ratios are given. Calculate the ratio of current through two wires. You have to find current ratios. How we can solve, students? We know that R equal to rho L by A formula. Then radius is given. If radius is given, you have to take the area equal to pi R square. Pi R square. Then how to write the resistance equal, students? This resistance I am writing as V by. This resistance I am writing as V by. Why I am writing V by? Because you have to write in terms of currents. 32 by 27. Very good. That is correct. Who given that answer? Fabio. Very good. I am writing R equal to V by. This is rho L by pi R square. Then you have to cross multiply. I equal to V into pi R square by rho L. V is constant. Voltage is constant. Where V is the voltage, sir? Rho is also constant. Resistivity for a given material, it is constant. Pi is, it's a constant value. Pi is the constant value. Then from this, what you can write, friends? I is proportional to R square by L. Shall I write like this? I2 by I1. Here it is asking that current ratios. Is asking the current ratios. Direct to calculate I1 by I2. If I1 by I2 not given, they will give the I2 by I1. But I1 by I2 equal to, how we can write? R1 square by R2 square into L2 square by L1 square. What is the ratios of the radius? So not L1 square. Length is not L2 by L1. What are the ratios of the radius ratio? 8:9. 8 by 9 whole square. Length ratio is 2:3. That is L1 is to L2. But here you have to write L2 by L1 na. That's why 3 by 2. Then we simplify this one, friends. 64 by 81 into 3 by 2. That is 32 by 27. 32 by. Therefore, the current ratios, the ratios of the currents I1 by I2 equal to 32 by 27. If 32 by 27 is not given, if they will give the 27 by 32. Sometimes I1 by I2 they will give, but both options they don't give. Okay, either I1 by I2 they will give or I2 by I1 they will give. Then current ratio is equal to 32 by 27. Then can anybody answer this question? Try, students. A current of 5 ampere is passing through a metallic wire of cross-sectional area 14 into 10 to the power of minus 6 meters square. If the density of the charge carries in the wire is 5 into 10 to the power of 26 per meter cube, find the drift speed of the electron. You have to find what is the drift speed of the electron. Friends, in the first class, I given the relation between current in terms of drift velocity or drift speed. I equal to N into E into A into VD. This formula, I equal to NEA VD. Then you have to find what is the drift speed. The drift speed equal to, how you can calculate, friends? I by NEA. How much current? It's a 5 ampere. How many number of electrons? How many number of electrons, friends? If the density of the charge is taken as a number of electrons, 5 into 10 to the power of 26. Electron charge, 1.6 into 10 to the power of minus 19 coulombs. What is the area? 14 into 10 to the power of minus 6. Here density of the charge carriers is nothing but these are the number of electrons per unit one. Per unit one. That is meter cube. Then you have to simplify this. What the drift velocity we can get? Can anybody? The drift speed VD equal to how much you get? 5 by 5 into 10 to the power of 26. 1.6 into 10 to the power of minus 19. 14 into 10 power minus 6. And by simplifying this, how much you can get? 4.46 into 10 to the power of minus 3 meter per second. Meter per second. Is it correct? All of you got? 4.46 into 10 to the power of minus 3 meter per second. Thank you. Next, how to try this practice? This question you have to practice, friends. Find the temperature at which the resistance of wire will be 2 ohms. The temperature coefficient of resistance of wire is 0.00125 per degree Kelvin with respect to temperature at 300 Kelvin, at which the resistance of wire is 1 ohm. Find the temperature at which the resistance of wire will be 2 ohms. Is 1 ohm. You find the resistance of the wire. That is R1 equal to 1 ohm, friends. You have to find what is R2. Relation you know, R2 equal to R1 into 1 plus alpha into delta T. Alpha into delta. That you have to calculate. Next. Can anybody answer these questions, friends? Right. All these models are framed in different computer exams. Can anybody? The resistance of a 1 kilowatt electric heater when energized by 230 volt single phase AC. What is the resistance? Given is heater. Na? I told already. Heater is the example of resistive. The heater rating P equal to V square by R. You find the resistance R equal to V square by P. What the voltage it is given, friends? The voltage is 230 volts. The voltage is how much it is given? 230 volts. Voltage equal to 230 volts. What the power it is given? Power equal to 1 kilowatt. Substitute here 230 square by power is 1000. How much you can get? Very good. Option A is correct. 52.9 volts. 0.9. Next. A conductor of diameter D length L consumes a power of W watt. W. When a current I flows through it, what will be the power consumed? If D is doubled, L is halved, and current is tripled. Can you try it? A conductor of diameter D length L consumes a power of W when a current I flows through it. What will be the power consumed if D is double, L is halved, and current is tripled? Yes, friends. We know that P equal to I square R. P equal to I square R. Shall I write like this? I square into what is R? You can write rho L by A. Rho L by A. Then we can also write I square into rho L by A. I am writing pi R square. A I am writing pi R square. Then what it is given? P equal to current is tripled 3I whole square rho into I am writing P dash. P dash I am calculating rho into length is halved. Doubled length is halved. That is L by 2 by pi into diameter is double means even radius is also double. Diameter is double means radius is double. This is equal to 9 by 2 into 4 into I square rho L by pi R square. I square rho L by pi R square is how many watts? W watt. W. Then what is P dash equals, friends? What is P dash equal? Power equal to? This is 9 by 8 W. 9 by 8 into W. All of you got? Very good. It's a 9 by 8. It's not very good. It's a 9 by 8. That is power becomes 9 by 8 times. Initially, if it is a W, now the power becomes 9 by 8 times. That you have to consider. Next. Can anybody? Everybody do this one and respond. What happens to resistance of a conductor if its length is increased 3 times and diameter is hollow? Length is increased 3 times and diameter is hollow. Length is increased to 3 times and diameter is hollow. R equal to same for rho L by A. R equal to rho L by A. Shall I write it? Rho L by pi R square. Length is increased 3 times. Length is increased 3 times. That this is rho L by pi R square. I am writing R dash. Rho into length is increased by 3 times. Next. And diameter is hollow. Diameter is hollow. Diameter is hollow means Even radius is also halved. That is 3 into 4 into rho L by pi r square. That is 12 into r dash. What is the rho L by pi r square? R. R dash equal to 12 times of r. Then resistance becomes how many times, friends? 12 times. Resistance is very increased by 12 times. Next. Can anybody answer this question? Come on, do it. You try this homework for practice, friends. Same model. Try to practice. And for this, we can get answer is approximately it's a 3125 ohms. Check it. Can anybody answer this question? I'm expecting answer from you. Fraction of minute you can answer. Come on, do it. Which option is correct? The resistance R of a conductor is. The resistance R of a conductor is. Option C. Is it correct? Yes. What is R equal to, friends? Rho L by A. R equal to rho L by A. Yes. We know that J equal to sigma E. First form of Ohm's law. From the sigma equal to J by E. What is sigma equal to? 1 by resistivity. What is the resistivity equal to? 1 by sigma. 1 by J by E. This is equal to E by J. Substitute here. R equal to, instead of rho, you write E by J into L by A. EL by AJ. EL by AJ. Is it correct? Is it correct? Correct or not? Resistance equal to EL by AJ. Every formula is useful to solve the problems. I got C, sir. Yes, that is correct. Option C is correct. EL by J. How to remember this formula? J equal to sigma E. This is first form of Ohm's law. This is the 2 marks question asked in GATE exam. Can anybody answer this? An incandescent lamp is marked 40 watt to 40 volts. If the resistance at room temperature is 26 degrees, is 120 ohms, and the temperature coefficient of resistance is 4.5 into 10 to the power of minus 3 per degree centigrade, then its on-state filament temperature, you have to find the T2. You have to find the T2. Right? Yes. We know the formula R2 equal to R1 into 1 plus alpha into delta T. At a incandescent lamp is marked 40 watt to 40 volts. If at room temperature 26 degrees centigrade, the resistance is how much, friends? 120 volts. That is R1 is 120 volts. Now, filament resistance depends on the, this is incandescent lamp. No? Incandescent lamp is the example of resistor. I told already. How to write P equal to V square by R. Then R equal to V square by P. What is the voltage? 240. 240 square by 40 square. Okay, this is equal to R2. This is equal to R2 square. During on state, the filament resistance, because of temperature, the resistance will increase us. Then what is that filament resistance? Can anybody? 240 square by 40 square. This is equal to 1440 ohms. Is it correct? 1440 ohms. Now you have to substitute here. 1440 equal to 120 into 1 plus alpha. Alpha is how much it is given? Temperature coefficient. 4.5 into 10 to the power of minus 3. Delta T. T2 minus T1. T2 minus T1. Okay. Then 1440 by 120 equal to 1 plus 4.5 into T2 minus T1 is 26 degrees centigrade. This T1 is 26 degrees centigrade. T2 is the after filament is heated, what is the temperature? After filament is heated, our resistance is 1440. Corresponding to this, what is the temperature? Now from this, you have to calculate T2. Can anybody? How much T2 you got? Very good. Okay, that is the correct answer. Approximately, I got the 2470.2470 degrees centigrade. Is it correct? Somebody is telling answer 2490. Can you try it? Is it 2490 is exact answer? This 0 cancel. This I'm doing simplification. Just a minute. I'm doing the simplification. This is 12 we get. 12 minus 1. 4.5 into 10 to the power of minus 3. 4.5 into 10 to the power of minus 3. 4.5 into 10 to the power of minus 3 is 4.5 into 10 to the power of minus 3. T2 minus 26. From this, what is the T2 minus 26 equal to? 11 by 4.5. This is 10 cube. That is 11,000 by 4.5. Then what is the 11,000 by 4.5, friends? That is approximately equal to, I'm doing the calculation, 11,000 by 4.5, 2,444, 2,444.4. Then what is T2? 2470, 2470.4 degrees centigrade. This is correct. This is exact answer I got. 2470.4 degrees centigrade. Yes. Yes, that is correct. 2470.4 degrees centigrade. This is the 2 marks modus. See, don't neglect any concept, whatever I'm explaining. From any concept, you can expect the questions. Don't think, sir, these formulas are not important for gate exam. Like, see, this is the gate exam question. It's a 2 marks question. So that is a T2 equal to 2470.4 degrees centigrade. Yes, friends. You have to try this. This also one more example. The resistance of a cube shaped material between any of its opposite faces is 3 ohms. If this material is strengthened in one direction by applying a linear force to double its original length, then the resistance between the opposite stretched faces have to calculate. What the resistance between opposite stretched faces? There is a cube, it is given. Let initially the resistance equal to R1 equal to the resistance R equal to rho L by S. The resistance R equal to rho L by initial resistance. This is how much it is given? 3 ohms. But point to remember, it is stretched. But assume that volume is constant. There is no change in the original value. There is no change in the original value. Then R dash. Then I'm calculating R dash. Let rho L by A, rho into the length is double. The length is double. That is 2L by what about the area? Volume is constant means V1 equal to V2. Let us assume that volume is constant. In two conditions, volume is constant. V1 equal to V2. We are stretching now. Volume is constant. If it is volume is constant, then L1 A1 equal to L1 A1 equals friends L2 A2. L2 A2. L2 A2. Shall I write like this? L1 A1 equal to L2 is double, length is double. That is 2L1 into A2. Then L1 L1 cancel. What is A2 equals, friends? A1 by 2. A2 equal to A1 by 2. Now you have to substitute. This is A by 2. Area is half. Area is half. Then what is R dash equal to? This 2 goes to the numerator, 4. 4 into rho L by A. This R dash equal to 4 into, what is rho L by A? 3. This is equal to 12 ohms. This answer is equal to 12 ohms. Here length is double. Length is double and volume is constant. Then you have to solve this one. I got R dash equal to 12 ohms. This question also you have to practice. Yeah, these are the different models of questions you have to solve with respect to resistance. With respect to resistance that you have to consider. Then one more topic with respect to resistance is that is the resistance color coding. Then after that we'll start the inductance. Yes, friends. Then why do go for the color codes? The color codes was developed in 1920s. That is Radio Manufacturers Association, that is RMA. Generally, if the resistors are very small resistors, that is the resistors are normally tiny resistors, that is very small resistors. And a small resistor, for example, if it is a small resistor, friends, if it is a small resistor, on this small resistance, if you want to print the value, for example, it is a 10 ohms or 100 ohms, printing this value is very difficult. And a small resistor, printing the value is very difficult. To overcome these problems, we go for the color codings, color bands. Resistors are normally tiny and it is difficult to print resistor values on them. So color bands are printed on them to represent the electrical resistance. According to color bands only, you have to calculate the resistance values. In these resistance values, the first band indicate the digit. The first band indicate the digit. First band indicate the digit. The second band also indicate the digit. The second band is also indicate the digit. Also indicate digit. The third band indicate the multiplier. The third band indicate the multiplier. Indicates multiplier. The fourth one indicate the tolerance or error. Fourth one indicates tolerance or error. I think you already done in the laboratory. This one. First band indicates digit, second band digit, third band is a multiplier, fourth band is the tolerance or error indicates. Then what is the value of tolerance you have to consider? In general, silver, the tolerance is taken as a plus or minus 10% for silver. For gold, the tolerance is taken as a plus or minus 5%. If none of the color is given, you have to take the tolerance is taken as a plus or minus 20%. Plus or minus 20%. This you have to remember. The first, this is the colors are black, brown, red, orange, yellow, green, blue, violet, gray, white. For black, first digit is 0, second digit also 0, multiplier is 1. For a brown, this is 1, multiplier is 10. Multiplier is 10. How to remember this sequence? I think you know this one. For remembering this sequence, there is one sentence is there. What is that sentence, friends? B.B. Roy, Great. How to remember the sequence, friends? Great Britain had a very good wife. Very good wife. This is the sequence. Black, brown, red, orange, yellow, green, blue, violet, gray, white. B.B. Roy, Great Britain had a very good wife. Then in the sequence, you have to remember. Now see how to calculate the resistance based on the color code. Why do you go for this color code, friends? If resistances are very small size, it's very small size. On that small size, printing the values are very difficult. That's why you go for the color coding. Then according given color coding, you have to calculate the resistance values. Then can anybody tell what the resistance of this one according to color coding? What is the first digit? First band. The first band is the digit. What is the number for that? What is color? Yellow, na? Yellow digit is how much? Yellow. This is 4. B.B. Roy. This yellow is 4 steps. 4. Next. What is the color? This is violet. Second one also digit you have. What is the number? Violet. 7. Violet is 7 steps. I'm calculating the resistance. This is yellow. 4. First digit is 4. This is also 4. But you remember 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. B.B. Roy, Great Britain had a very good wife now. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the numbering you have to remember. Understood, friends? Then violet number is how much? This violet now 7. 47. This is digit. First band is also digit. Second band is also digit. Third band is the multiplier. What is that color, friends? Orange. What is the orange multiplier? How to remember this one? 1, 10. This also you have to remember. 1, 10, 100. 1, 10 square. Sorry, 1, 10, 10 cube, 10 square. How to remember? This is 10. This is 10 square, 10 cube, 10 power 4, 10 power 5, 10 power 6. Like this you have to remember. Orange multiplier. Third band is the multiplier into 10 cube. Plus or minus. Fourth band is the tolerance. What are the tolerance, friends? What is the given color? This is gold. You have to take tolerance is how much? Plus or minus 5%. This is the value of this resistance. that is 47,000 plus or minus or 47k kilo ohms. How to write up? What is that resistance value? 47 kilo ohms plus or minus 5%. Clear, friends? How to calculate? Can anybody tell what is the answer for this? I'm expecting answer from you. First two bands are digits. Number you write. Third band is multiply. Fourth band is which one? Fourth band is tolerance. First two. What is the color this one? Orange. Sorry. What is the color this one, friends? It's a red color. Red or orange. This is what color this? Now take this is the red. This is also red. But this I taken, this is orange. No? In orange, that is 10Q. This is 10Q. I taken this color is orange. Okay, some differences, but red. Then red is 2, 2. 2, 2. Both are red. 2, 2. Then what is the multiplier? This is black. Black multiplier is 1. Black multiplier, sir. Multiplier is 1. Then what about this one? Gold. They given here. Red. They given red. They given red, red. This is black. Plus or minus. Gold tolerance. What is the gold tolerance? 5%. What are the answers, friends? 22 ohms plus or minus 5%. 22 ohms plus or minus 5%. This is a calculation. Students, simply remember 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm writing once again. How to remember? Starting 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. BB Roy. This one. BB Roy. Great Britain. Great Britain. G. Next, Great Britain. B. Had a very. V. Good. G. W. Then what is the multiplier? This is digits. These are the digits. The first digit and second digits are same. Same values for every color. And multiplier. And multipliers. Multipliers are 1, 10, 10 cube, sorry, 10 square, 10 square, 10 cube, 10 power 4, correct? 10 power 5, not right, 10 power 6, and so on. These are the multipliers. The digits are first and second digits values are same. Like this you have to remember. This is color coding students. Can anybody answer this question? Even based on color codings also, in ESC there is a question is there. This I am solving this question. Come on, do it. What is the answer? First band color is yellow, second band color is violet, third band is red, fourth band is silver. Silver is, what is the tolerance? 10%. Means simply, this is not the answer, this is not the answer. Okay. Yellow. Yellow is first band. What is the value of yellow? 4. Next, violet. What is the value of violet? Violet, friends. 7. 7. Next, which is given? Third band. Third band color is red. What is the red multiplication? 10 square. Multiplier is 10 square. Plus or minus 10%. That is 4.7 kilo ohms. 4.7 kilo ohms plus or minus 10%. Which option is correct? Option B is the right answer. Very good. Any doubt, sir? Just remember this statement, this sentence, and write down 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Multiplication 1, 10, 10 square, 10 cube, like that. First digit number, second digit numbers are same for every color. 2, 2, 3, 3. Every color same number. First digit and second digit. In color coding, first band is digit. Second band is also digit. Third band is multiply. Fourth band is which one, friends? Tolerance. Tolerance in the sense you have to take the plus or minus. This is about the detailed discussion of what exactly the concept of resistance is. The concept of resistance is completed. The next session we have to see what exactly the concept of inductor and capacitor. Any doubt? Any doubt, friends? Okay, thank you. This is about the today's session. I will share this PPT. Please go through once again. Every day, whatever the concepts I am explaining, students, you have to parallel, you have to prepare. Don't postpone. Okay, thank you very much. I'm ending the session.